Good afternoon. Here we have the solutions to our quiz, chapter 5 and 6. And we are going to go ahead and get started. So number one, so the directions to this say simplify. So number one, we have negative 4, a to the negative fifth, inside parentheses, and we are multiplying that times 2, a to the negative third, inside parentheses. So what I want you to, anytime that you're multiplying or dealing with exponents, I always want you to look right outside the two parentheses first. You need to make sure there's not an exponent outside of that you need to give to everything inside. That's really what you look for first. Is there an exponent on the outside of the parentheses that I need to give to everything inside the parentheses? And the answer to that on both of these is no. So I can go ahead and start dealing with the stuff on the inside. So the first thing that I'm going to deal with is I'm going to deal with my negative 4 and my positive 2. So negative 4 times positive 2 is going to be negative 8. Okay, the next thing I'm going to deal with is my a to the negative fifth and my a to the negative third. So those are being multiplied together and they have the same base. So the exponent rule, when we do that, when we are multiplying and they have the same base, is that we add their exponents together. So I have a to the negative fifth plus negative 3. Okay, so I've got my exponent here, and I'm adding those together. So I end up with negative 8 a to the negative 8. Now, this negative that is associated with the 8 and the coefficient gives the value of a negative to the 8. Okay, we're not moving anything to the denominator. It's just that 8 is negative. Now, this negative 8 is the exponent, and that is the one where we're using the reciprocal. So this a to the negative 8 is going to move to the denominator, and it's going to become a to the 8th. The negative 8 that's the coefficient that's in the numerator, it stays. You don't do anything with that because that's not raised to a negative exponent. That's just a value that's negative. So my final answer to this is negative 8 over a to the 8th. Okay, let's look at number 2. Number 2 is 2x to the negative 2 times y to the third. All of that is over 3x y squared z to the negative fourth, and then the entire thing is raised to the negative third power. Depending on the situation, sometimes I would simplify everything that's inside the parentheses first. And you certainly could do that. You've got some x's and some y's that could be combined, and you've got a z to the negative fourth that could move to the numerator. However, if you look here, this is a negative 3. A lot of times when I've got a negative exponent on the outside of the parentheses, some of the negatives on the inside, or all of the negatives on the inside of the parentheses, are going to become positive. So if I moved a lot of stuff around on the inside, I'm just going to have to turn right back around and move it again. So I'm going to give this negative 3 to everything inside my parentheses first. Okay? And that includes the numbers. Sometimes students forget that negative 3 belongs to everything inside the parentheses, including the numbers. So that's going to be 2 to the negative third. Then I am going to have x to the negative 2 times negative 3. And there's one of those situations where my x has a negative exponent, but as soon as I multiply it times the negative 3, I get a positive exponent. So that's why I chose to do this first. Then I've got y to the third times negative 3, and that's my numerator. My denominator is 3 to the negative third, x to the negative third, y to the 2 times the negative 3, and z to the negative 4 times negative 3. Okay, so I'm going to go ahead and simplify. I'm not going to move things to the numerator and denominator yet. I'm just going to start simplifying. So I've got 2 to the negative 3. Then I have x to the 6th, because the negative 2 times negative 3 is positive 6. Then I have y to the negative 9. Okay, 3 to the negative 3, x to the negative 3. Then I have y to the negative 6, because 2 times negative 3 is negative 6. And then I have z to the positive 12. Okay? Now I'm going to start moving things from the denominator and the numerator. So here I've got 2 to the negative 3. Because of that negative exponent, that's going to be 2 to the third in the denominator. Okay, my x to the 6th is going to stay in the numerator. But my y to the negative 9 is going to go to the denominator, and it's going to be y to the 9th. Okay, now let's look at my denominator. 3 to the negative 3, that's going to go to the numerator and become 3 to the third. Okay, then I have x to the negative 3, that's going to go to the numerator and become x to the third. My y to the negative 6th is also going to go to the numerator, and it's going to become y to the 6th. Okay? The z to the 12th stays in the denominator because it's a positive exponent. Now, I'm going to go ahead and start simplifying. I have 3 to the third. Now, you don't have to simplify that, but a lot of time, I would accept 3 to the third, but you can. 3 times 3 times 3 is 27. So that's an exponent that I believe that you can easily simplify. Now I have x to the 6th and x to the third in the numerator. When we have those x to the 6th and x to the third, we add those exponents together. So I have x to the 9th in the numerator. And then the last thing I'm left with is y to the 6th in the numerator. Okay, in the denominator, I have 2 to the third. 2 times 2 times 2 is 8. Then I have y to the 9th, y to the 9th, and z to the 12th. Now, we're not quite finished yet because I have a y to the 6th in the numerator and a y to the 9th in the denominator. Now, I've got more y's in the denominator than I do the numerator. But I can cancel completely my y's in the numerator. So these y's are going to be completely gone. This y to the 9th becomes y to the third because 9 minus 6 is 3. That y stays in the denominator because I had more y's in the denominator when I got started. So my final answer to this is 27x to the 9th over 8 y to the third z to the 12th. And that's my final answer. For future reference, if you're 27 and you're 8, if your numbers can simplify, then you would go ahead and simplify those numbers. But 27 and 8, nothing goes into both of those. Okay, number 3. We've done a lot with the square root of 48. So you may be remembering that the square root of 48 breaks down to the square root of 16 times 3. Okay, and the reason that we pick 16 is because 16 is the largest perfect square. So I'm going to take the square root of 16, which is 4, and then I move the 4 to the outside, and I'm left with the square root of 3. So I have 8 on the square root of 3, and that 8 on the square root of 3 is my final answer. However, very often I have students that don't immediately see that there's a 16 in 48. So I encourage you to go ahead and break it down by primes. So 6 times 8 is 48. 6 is 2 times 3. 8 is 2 times 4. And 4 is 2 times 2. So I am looking at my primes. So 2 times 2 is 4, times 2 is 8, times 3 is 24, times another 2 is 48. So that 2 times 2 times 2 times 2 times 3 is the prime factorization of 48. So I am going to rewrite this as 2 times 2 times 2 times 2 times 3. Okay, so if I have 2 on the inside of my square root sign, I have a set of 2's, I have 2 sets of 2's, then I can pull one of them out. So I already have a 2 on the outside. So this set of 2 produces a 2, and this set of 2 produces a 2. And then I'm left with a 3 on the inside. So if you can't see that 48 is 16 times 3, then you can see, you can do the prime factorization. And you can, once you have a set of 2 numbers, then you can pull those out. So then 2 times 2 times 2 is 8, and we get 8 on the square root of 3. And so either method is 100% correct. Okay, number 4. I have the square root of 27 over the square root of 2. So what we're going to do here is we have to get rid of that square root of 2. Something is not fully simplified unless we have eliminated the square roots in the denominator. So here I've got the square root of 2 in the denominator, so I have to get rid of that. So my square root of 2, I am going to multiply it by the square root of 2. Because when I multiply square root of 2 times square root of 2, then I'm going to get 2, which is what I want. But I can't multiply the denominator by something and not multiply the numerator by something. So I have to multiply everything by the square root of 2 over the square root of 2. Because the square root of 2 over the square root of 2 equals 1. And that's why I'm allowed to multiply by the square root of 2 over the square root of 2, is because I'm multiplying by 1. So square root of 27 times 2, or times the square root of 2, is the square root of 54. And that is over the square root of 2 times square root of 2, which is the square root of 4, which then gives me the square root of 2. Now, some students stop at this point. I wouldn't, because there's a perfect square in 54. 54 simplifies to 9 times 6, and we can take the square root of 9. And so that's 3 on the square root of 6 over 2. At this point, you would look and see if 3 and 2 can be simplified further. They can't, and so you are done. So I want to go back to this step right here, where I have square root of 54 over 2. You cannot divide the 54 by 2. And the reason that you can't is because the square root of 54, the 54 is inside the square root sign and the 2 is outside. In order to divide, you would have to have both in or both out. You can't divide or simplify when you've got one number inside the square root and one number outside the square root. Okay, so that's something that I want you to realize is super important. The other thing that I want you to realize is that if you don't know that 54 is 9 times 6, or you don't identify that 9 is a perfect square, you can do the prime factorization of 54. So 54 is 2 times 27. 27 is 9 times 3. And 9 is 3 times 3. Okay, so my prime factorization of 54 would be 3 times 3 times 3 times 2. Okay, I have a set of 3's right here, and if I have 2 3's inside the square root, that simplifies to 1 3 on the outside. And then 3 times 2 is 6. So that's how I could do the square root of 54 if I can't immediately identify that there's a 9 in there. Okay? Let's solve some equations. Okay. So, I have x equals the square root of x plus 13 plus 7. Now, some of you got confused because you didn't know what to do with that plus 7. You knew that you had to square both sides, but you forgot that you've got to isolate that square root first. So this right here has to be completely by itself before I can square. So the first thing that I'm going to do is I am going to subtract 7 from both sides. And when I do that, then my square root is isolated. So I have x minus 7 equals the square root of x plus 13. So at this point, I am going to square both sides. Okay. When I square the square root of x plus 13, I'm left with just x plus 13. Now, x minus 7 squared, I have to FOIL. Okay, I have to FOIL that. And sometimes students forget that you have to FOIL, and they just end up with like x squared minus 49 or x squared plus 49. But x minus 7 squared has got to be FOILed, and that means x minus 7 times x minus 7. So I have x times x, that's x squared. X times negative 7 is negative 7x. Negative 7 times x is negative 7x. Negative 7 times negative 7 is plus 49. So I have x squared minus 14x plus 49. And that is my trinomial. Okay, so I am going to write that down over here for my x minus 7 squared. So I have x squared minus 14x plus 49. Now I've got to get my x squared, because it's a quadratic, I've got to set it equal to 0. So my next step is I am subtracting x from both sides, and I am subtracting 13 from both sides. Okay, so when I do that, I have 0 on the right-hand side. On the left-hand side, I get x squared minus 15x plus 36. And that can be factored very nicely. So it factors to x minus 12 and x minus 3, because negative 12 times negative 3 gives me positive 36, and negative 12 plus negative 3 gives me negative 15. Okay? So now I set each one of them equal to 0. So I have x minus 12 equals 0, and x minus 3 equals 0. So my values for x are 12 and 3. However, we have to check it. If we don't check it, we run the risk of having an extraneous solution that we don't eliminate. So we have to check both of these. So the first one I'm going to check is 12. So I'm plugging 12 in for x. So I have 12 equals the square root of 12 plus 13 plus 7. 12 plus 13 is 25, so I have 12 equals the square root of 25 plus 7. So 12 equals 5 plus 7, and that works. So we're in good shape. Okay, now I'm going to check my 3. So we've got that x equals 12 does work. Now I'm going to check my 3. Okay, so I have 3 equals the square root of 3 plus 13 plus 7. 3 plus 13 would be the square root of 16. Okay, square root of 16 is 4, so then I have 3 equals 4 plus 7, and that is not true. So I have to throw this out. So my answer is only x equals 12. So don't forget to check those. That's super, super important that we check those. Okay, so now let's move on to number 6. So I have 4x squared equals 1 plus 7x. Now, it's a quadratic, and we know it's a quadratic because of the x squared. So anytime that we have an x squared, we've got to set it equal to 0. Before I can make any decisions about anything, I've got to set it equal to 0. So the first thing that I'm going to do is I'm going to subtract 1 from both sides, and I'm going to subtract 7x from both sides. Okay, that's what I'm going to do first. Then I am left with 4x squared minus 7x minus 1. So I have moved the 1 and the 7x to the other side. So I always ask myself if I can factor it. So I've got a product of negative 4. That's my 4 times my negative 1. And I have a sum of negative 7. And there are no numbers multiplied together that give me negative 4 and added together give me negative 7. So I can't factor this. So my choices are quadratic formula or completing the square. Now I am going to do the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac over 2a. Now the blue is stuff that I have to substitute in, and the red is part of the quadratic formula. So I'm going to go ahead and identify my a. My a is 4, my b is negative 7, and my c is negative 1. Okay, so we've got to be careful with all these negatives. Now, the reason that I chose quadratic formula over completing the square is because of this number right here. Okay, that 4. Completing the square works best when I have a 1 right there. When I have a 1 right there and my b value is even. Neither is true for this. And so for me, the quadratic formula is the best way to go. However, you can certainly do completing the square. And I will do completing the square on number 7. But for this one, it just makes it pretty complicating. So I have negative b. So negative, and my b value is negative. So that's negative 7. Okay? Plus or minus the square root. And I am going to square b. So put that negative 7 in parentheses. You're going to be much better off if you do that, because then you know that you're squaring the negative and the 7. Then I have minus 4 times a times c. And that is all over 2 times a. Okay, now I'm going to start simplifying. Negative 7 is positive 7, plus or minus the square root. Negative 7 squared is 49, and it's positive 49 because I'm squaring the negative. Negative 4 times positive 4 is negative 16. Negative 16 times negative 1 is positive 16. Okay, and 2 times 4 is 8. So now I have 7 plus or minus the square root of 65, and all of that is over 8. 65 factors to 13 and 5. So I can't break that down anymore. So this is my final answer right here. And remember, that's 2 answers. It's 7 plus the square root of 65 over 8 and 7 minus the square root of 65 over 8. You don't have to rewrite that, but I want you to be aware that that is 2 different answers. Okay. Number 7 is a quadratic. It's not set equal to 0 yet, so we got to do that first. So I'm going to subtract 15, and I'm going to subtract 4x. So I have both of those subtracted. So I'm left with x squared minus 4x minus 15 is equal to 0. Okay? My product that I am looking for is negative 15. And my sum is negative 4. And there are no numbers that I multiply together that give me negative 15 and add together and give me negative 4. But the nice thing about this one is it is a nice completing the square. So I've got a 1 in front of this x squared, and I have an even b value. So this works beautifully for completing the square. So the first thing that I'm going to do when I'm completing the square is I'm going to move this negative 15 back to the other side. Okay? So I have x squared minus 4x equals positive 15. Okay? Now I'm going to take 1/2 of negative 4. So half of negative 4, that's negative 2, and then I'm going to square that. So I have negative 2 squared, which is positive 4. So I am adding positive 4 to both sides. And by design, I have created a perfect square trinomial. So I have x squared minus 4x plus 4. That is a perfect square trinomial. And it factors to x minus 2 times x minus 2. Negative 2 times negative 2 give me positive 4. Negative 2 plus negative 2 give me negative 4. Okay, that's why that works. So this factors to x minus 2 squared. And that equals 19, and 15 plus 4 is 19. Now I'm going to take the square root of both sides. When I take the square root of 19, I have to add that plus or minus. Don't forget that you've got to add that plus or minus. So I have x minus 2 equals plus or minus the square root of 19. My final step is to add 2 to both sides. And I have x equals 2 plus or minus the square root of 19. Okay, and again, that's two different answers. My answer is 2 plus the square root of 19 and 2 minus the square root of 19. Now, if you had done the quadratic formula, you would have gotten the exact same answer. You would have had to simplify, but you would have gotten the exact same answer. Okay? Now, this next one was definitely the hardest one on the quiz. Okay? We have a rational, and we are actually going to get an irrational solution to this rational equation. So the very first thing I have to do is I have to find the LCD. I have to find the LCD. So I need to rewrite this x squared minus x minus 2. I need to factor that. So I'm going to have 2 over x minus 1 plus 1 over x plus 1 equals 1 over, and this factors to x minus 2 and x plus 1. Okay? X minus 2 and x plus 1. So my LCD here, I'm going to start with my x minus 2 and my x plus 1, x minus 2, x plus 1. Okay, so I've got both of those covered. Then I've got my x plus 1 covered, but I don't have x minus 1. So x minus 1 is also part of my LCD. So I have 3 binomials as part of my LCD. And as you know, my next step is to multiply everything times my LCD. Okay, and that's over 1. So here we go. I have 2 over x minus 1 times x minus 2 times x plus 1 times x minus 1 over 1. Then I have plus 1 over x plus 1 times x minus 2, x plus 1, x minus 1. And that is equal to 1 over x minus 2, x plus 1, times x minus 2, x plus 1, x minus 1. Now we're going to start canceling. Okay, so I have x minus 1 and x minus 1. So now I've got 2 times x minus 2 and x plus 1. Okay, so we are going to have to FOIL that. We're going to have to FOIL that. Then I've got x plus 1 and x plus 1. And so I'm left with x minus 2 and x minus 1. And then x minus 2 and x plus 1. And so on the right-hand side, I'm left with x minus 1. Now, my next step is to FOIL here and to FOIL here. I would FOIL before I distribute the 2. That's just what I would do. You could distribute the 2 and then FOIL, but you would only distribute the 2 to the first binomial. You wouldn't distribute it to both. I would do the FOIL first. So when I FOIL x, so I'm FOILing x minus 2 times x plus 1. Okay, x times x is x squared. X times 1 is x. Negative 2 times x is negative 2x. Negative 2 times 1 is negative 2. So my first trinomial is x squared minus x minus 2. Okay, and that is what I'm going to multiply 2 by in just a minute. So I have x squared minus x minus 2. Okay, now I want to FOIL my next binomial, or my next two binomials. So I have x minus 2 times x minus 1. X times x is x squared. X times negative 1 is negative 1x. Negative 2 times x is negative 2x. Negative 2 times negative 1 is positive 2. So I have x squared minus 3x plus 2. Now, I don't have anything that I need to distribute this one by. So I'm just going to have x squared minus 3x plus 2. Okay. I've got one more distribution, and then we can start simplifying. So now I'm going to distribute my 2 with that first trinomial. So I have 2x squared minus 2x minus 4 plus x squared minus 3x plus 2 equals x minus 1. Okay. So I am going to go to the next page. Let me make sure I've got this written down so I can move this to the next page correctly. Okay, so all I'm doing now is rewriting what we had on the last page. So I have 2x squared minus 2x minus 4 plus x squared minus 3x plus 2 equals x minus 1. So now I'm combining like terms. So I have a 2x squared and an x squared. So that means I have 3x squared. Okay, now I've got a negative 2x and a negative 3x. So here I've got minus 5x. Now I haven't dealt with that x on the other side yet. I'm just dealing with the stuff on the left-hand side. Then I have a negative 4 and a positive 2. Okay, negative 4 and positive 2 gives me negative 2. Okay, that equals x minus 1. So now I'm going to subtract x from both sides, and I'm going to add 1 to both sides. Okay, so now the trinomial that I'm dealing with is 3x squared minus 6x minus 1 equals 0. Okay, that's where we are. 3x squared minus 6x minus 1 equals 0. Okay, my product for this would be negative 3. That's my product. My sum would be negative 6. There are no two numbers multiplied together that give me negative 3 and added together give me negative 6. So I'm going to have to use the quadratic formula. And the reason that I'm using the quadratic formula and not completing the square is because I've got an a value that's not 1. This is even, but if I've got the a value that's not 1, then I usually don't use completing the square. I've got to have both, an a value of 1 and an even b value. So I've got negative b. You're going to have this memorized. Plus or minus the square root of b squared minus 4 ac. Again, the blue you've got to plug a number in. The red is part of the equation. Over 2 times a. Okay, so my a value is going to be 3. My b value is negative 6. My c value is negative 1. Okay, here we go. So I have negative b, and b is negative 6, plus or minus the square root of negative 6 squared minus 4 times a times c. And all of that is over 2 times a. Okay, now I'm going to simplify what's inside. So I have negative 6, so that's 6, plus or minus the square root, and I have negative 6 squared is 36, and that's positive because the negative is being squared. Minus 4 times 3 is negative 12. Negative 12 times negative 1 is positive 12. So I'm adding 12, and then in my denominator, I've got 2 times 3, which is 6. Okay, now I'm moving right up here. So I'm going right here. So I have 6 plus or minus the square root of 48 over 6. Now I'm hoping by now you have started to remember that that 48 can be broken down into a perfect square. And we have broken it down lots and lots of times. So remember, the square root of 48 breaks down to 16 times 3. 16 times 3. It does break down to 4 times 12, but 4 is not the largest perfect square. 16 is the largest perfect square. So now I have 6 plus or minus. I'm going to simplify the square root of 16. The square root of 16 is 4, so I'm bringing that to the outside. So I've got 4 on the square root of 3 over 6. Now, in order to simplify, I've got to have a factor that goes into the 6, the 4, and the 6. And the number that goes into all of those is 2. So 2 goes into 6 3 times, 2 goes into 4 2 times, and 2 goes into 6 3 times. So my final answer here is 3 plus or minus 2 on the square root of 3 over 3. That's my final answer. Now, every once in a while, so I'm going to circle this right here as my final answer. Every once in a while, I've got, so I'm going to go back to 6 plus or minus 4 on the square root of 3 over 6. I have students that like to do 6 over 6 plus or minus 4 on the square root of 3 over 6, and that's completely fine. Completely fine. So 6 over 6 is 1, so then I would have 1 plus or minus 2 on the square root of 3 over 3. Okay, and that's because this 4, a 2 goes into 4 twice, and a 2 goes into the 3 times. Now, the 3 that's inside the square root and the 3 that's outside the square root cannot be simplified. And the reason is, to simplify it, they both have to be in or they both have to be out. So you would get 100% credit if you had 1 plus or minus 2 on the square root of 3 over 3, or if you had 3 plus or minus 2 on the square root of 3 and all of that over 3. Okay? Thanks so much.